right, so today we are on inverse equations. Our learning targets are to solve equations by using inverse trig functions and to find values of expressions involving trig functions. So the question here is, if the sine of x is equal to 1/2, what is x? X being the angle. So, and that we're doing that in radians here. So it's possibly that we could have two angles there. So let's look at where on the unit circle is the sine or the y value equal to 1/2. So if I look, I can see a 1/2 there, and I can see a 1/2 there. So what are those two angles in radians? We have pi over 6, and we have 5 pi over 6. Remember, on your unit circle, it always goes cosine and then sine for your ordered pairs, or x comma y. So we were looking for the y value, which was our sine. So we have what's called inverse trig functions. In order for a function to have an inverse, it must be 1-to-1 and pass the horizontal line test. Basically, trig functions are not 1-to-1 because if you try to do the horizontal line test on these trig functions here, you will end up failing the horizontal line test. So we have to restrict the domain on these. So if you notice where it got restricted here, it's restricted here for sine function here. This is your sine. It's restricted there from negative pi over 2 to pi over 2. And then down here is cosine. Cosine is restricted from 0 to pi. And then tangent is restricted from pi over 2, or negative pi over 2 to pi over 2. So that way it'll pass the horizontal line test. All right, so let's start to look at the definition of inverse trig functions. So we're going to look at the inverse sine, and this is how it's written, the inverse sine. It's also called the arc sine, but most people are going to probably refer to it as the inverse sine. So it says if the inverse sine of x is equal to y, then the sine of y is equal to x. So then they state the domain and range there. So let me kind of come down here and explain to you where that came from. So if you remember how our graphs here go, so if I were to graph this out here, your sine graph, I could back it up. Would look like that. So our restriction here is from negative pi over 2 to pi over 2 here. Normally your domain here for your sine function here would be negative infinity, comma infinity. That's your x values. And then your range here would be from negative 1 to 1. Well, they swap with the inverse. So your range becomes your domain, and your domain becomes your range, but because we have a restriction here from negative pi over 2 to pi over 2, that becomes our range because it has to pass that horizontal line test. All right, so since that's true, and we've got that restriction going on here, the sine is restricted to quadrant 1 and quadrant 4. Why is that? Because it's from negative pi over 2 to pi over 2. Well, negative pi over 2 is the same thing as 3 pi over 2, and it goes up through pi over 2. So it's restricted to quadrant 1 and quadrant 4. So when we find the inverse sine of 1/2, and we're specifically trying to find that value, even though you've got a 1/2 here, up here in quadrant 1, and you have one over here in quadrant 2, because it's restricted to quadrant 1 and quadrant 4 here, you can only pick pi over 6. All right, so now let's look at cosine. So for cosine here, I'm going to draw a graph down here. So graphing this function out here, backing it up. So looking at this one here, because of the restriction here, we're restricting it here from 0 to pi for this one. So normally our domain for this one would be negative pi to pi, and our range here would be from -1 to 1. So our range would become our domain in the inverse, and we normally our domain then would become our range there, but that's not going to happen because of the restriction. And so this domain becomes this range. So it's from 0 to pi. So from 0 to pi here, that means we're from here over to here. So we're in cosine is restricted to quadrant 1 and quadrant 2. All right, so now coming up here, we're supposed to find the inverse cosine there of square root of 3 over 2. So looking at the square root of 3 over 2, which quadrants are those in? Well, square root of 3 over 2 for cosine is at pi over 6. And the inverse cosine there is square root of 3 over 2 is also there for 11 pi over 6. So we're restricted to quadrant 1 and quadrant 2, so which angles work? Only pi over 6. All right, so now we're on tangent. So before we do the inverse tangent, just like the others, let's go ahead and graph out the tangent graph. So graphing this one out here, remember for tangent you've got asymptotes here at negative pi over 2, pi over 2, 3 pi over 2. So halfway in between here, whoops, I should probably put our 1 and -1 on here. So graphing this out, we've got a value here at 0, then this one's down here at -1, this one's up here at 1. And I can connect those down here at, over here at 0, down here at -1, up here at 1. Connect those. And it keeps repeating. So the normal domain and the normal range here, the range for tangent here is from -infinity to infinity, because it starts down and then goes up forever. The range here, or the domain here for this one here is different this time. It goes x such that x cannot equal pi over 2 plus pi over n, where n is any integer. So all we're saying with that is that you've got asymptotes here at negative pi over 2, at pi over 2, at 3 pi over 2, at 5 pi over 2, 7 pi over 2, 9 pi over 2, and all those have the asymptotes at it, so they can't be those because it approaches those values but doesn't equal those values. So now our range becomes our domain, and our domain becomes our range, but our domain here, remember, is limited, is restricted. So we're going from negative pi over 2 to pi over 2. So we're taking that one for our domain. So that means if we're going from negative pi over 2 to pi over 2, so that's negative pi over 2 there is the same thing as 3 pi over 2, and it goes up here to pi over 2. So tangent is restricted to quadrant 1 and quadrant 4. So then let's come down here and let's look at the inverse tangent of -1. So looking at that value there, we've got two places where that occurs there on the unit circle here. We've got negative square root of 2 over 2 divided by square root of 2 over 2 will give us -1. So we need one to be positive and one to be negative where they're the same value. And the other one up here is at 3 pi over 4. But 3 pi over 4 is up there in quadrant 2 and tangent restricted to quadrant 1 and quadrant 4. So this has to be 7 pi over 4. But because we're writing it as negative pi over 2 and pi over 2, we're going to say this is negative pi over 4. Because that would be the same thing as 7 pi over 4. So with these inverse signs, people get mixed up a lot in knowing when do you have one answer and when do you have two answers. So if you don't have an x in it, basically you're going to have one answer. So what's the square root of 4? It's 2. So there's just simply one answer. So there's no variable in that one. Likewise, when you're doing the inverse sign of 1/2, there's only one place where that exists. It exists there at pi over 6. It's one answer. Right, because we can't include the other one because it's not within its restrictions. All right, so x squared plus 4 there, it has an x value in there or a variable in it. And so to solve that, you would have to go ahead and take the square root of both sides, and you end up getting x equals plus or minus 2. All right, so when you have a sine of x is equal to 1/2 and you're trying to find the answer here, there's going to be two answers. Because to solve this, you look on the unit circle, where is a sine equal to 1/2? Well, a sine is equal to 1/2 in two places. It's at pi over 6 and at 5 pi over 6. All right. So that's the way you're going to kind of look at those. If it's got a variable in it and you're trying to find the variable, then you're going to have two answers. If you just have numbers and there's no variables in it, it just has a single one answer. All right, so let's find the exact value of each expression if it is defined. So the inverse sine of square root of 3 over 2. Well, sine is only defined in two quadrants. It's in quadrant 1 and quadrant 4. So where is your sine there? The square root of 3 over 2. It's only there, and it's at pi over 3. All right, so now we're on inverse cosine. Inverse cosine there is defined in quadrant 1 and in quadrant 2. So where is your inverse cosine there equal to the negative square root of 3 over 2? And that's there at 5 pi over 6. We also have the inverse cosine there at 4. Well, the inverse cosine will never equal 4. It has to be something that's in between -1 and 1. So this is not defined. So there are some inverse sine rules here. So you can see what those values there actually are. So if you take the sine of the inverse sine, you get x. If you take the inverse sine of the sine there, you get x. So, and that's provided that in each one of those cases that follows the rules there, that follow there in the brackets there, that x is in between -1 and 1, then that's true. If x is in between negative pi over 2 and pi over 2, then that's true for the second one. And so on and so forth. You can see how they're defined as you go down the page. So let's go ahead and find the exact values if they exist. So the cosine of the inverse cosine there of 3/4 is 3/4. Again, it's defined, it's in between -1 and 1. The tangent of the inverse tangent there of 8 is 8 because it's in between -infinity to infinity. And you could check these on your own graphing calculator if you wanted to. You could do the cosine of the inverse cosine there of 3/4, and it would tell you it's 3/4. You could do the tangent of the inverse tangent there of 8, and it will tell you it's 8. Likewise, over here, we're supposed to find the exact values if they exist. The sine of the inverse sine of the square root of 2 over 2 is the square root of 2 over 2. And the sine of the inverse sine there of 3, it's not defined. So again, if you don't remember that it has to go between -1 and 1, you can always just plug these into your calculator and do the sine of the inverse sine of 3, and it will error on you, telling you that it's not defined. All right, so sometimes you have to take these one step at a time, because as I'm looking at this, you know, cosine is only defined there in quadrants 1 and quadrant 2. If you do the inverse cosine of the cosine of -π/3, you're thinking, oh, my answer there has to be -π/3, but -π/3 is not in quadrant 1 or quadrant 2 there. It's down here in quadrant 4. So let's see, let's just walk it step by step here to see what our real solution here is. So let's find the cosine of -π/3. So the cosine is defined in all 4 quadrants here, so I can actually find the cosine of -π/3. So π/3 is here, so I can go in the same direction in the other direction here. So I get 5π/3. So what's the cosine there at 5π/3? The cosine there is 1/2. So now let's look there at the inverse cosine of 1/2, knowing that inverse cosine is only defined there in quadrants 1 and 2. So where is your cosine there equal to 1/2? It's equal to 1/2 there at π/3. So your solution there is π/3. Not -π/3, but π/3. All right, so let's work these one step at a time here. So the inverse sine of a square root of 2 over 2. So sine is defined there in quadrants 1 and 4. So where is your sine there, the square root of 2 over 2? And it's there at π/4. So therefore we need to find the tangent of π/4. So the tangent of π/4 there is the same thing as the sine of π/4 divided by the cosine of π/4. And we know that to be the square root of 2 over 2 divided by the square root of 2 over 2, which gives us a value of 1. So our solution there is simply 1. So now let's come down here and look at the next problem here. We have the cosine of the inverse sine of 1/2. So again, looking there at the inverse sine, so that's defined in quadrant 1 and in quadrant 4. So where is our inverse sine there, 1/2? Well, our inverse sine there is 1/2 there at π/6. So what's the cosine at π/6 there? It's the square root of 3 over 2. So that means this is the square root of 3 over 2. So there we have it. All right, so we're going to sketch a triangle to solve this problem here. So the cosine of the inverse sine there of 3/5. So let me draw out a triangle here, sketch it in here. So the sine of theta there is equal to the opposite over the hypotenuse. So I'm working on the inside right now. And we're being told here that your sine there is 3/5. Or sine of some angle there is equal to 3/5. So here's across from my angle here is 3, which is my opposite. and this is my hypotenuse. And we know that to be 5 from that 3/5 there. That's 3 over 5, opposite over hypotenuse. All right, so to be able to solve this problem, cosine is adjacent over hypotenuse. Well, we have the hypotenuse. We know that to be 5, but we don't have the adjacent. So the adjacent is here. And so we can go ahead and solve this triangle here, this right triangle here, using the Pythagorean theorem. So I'm just going to call this adjacent side here x. So I'm going to say x squared plus 3 squared equals 5 squared. I'm going to subtract 9, take the square root, and it's not going to be plus or minus 4 because the side length cannot be negative 4, so it has to be 4. So this adjacent there is 4. So I can come over here, and my adjacent or my hypotenuse there is 4/5. So we are supposed to find the cosine, the inverse sine of 3/5. It is 4/5. So I'm supposed to sketch out a triangle to solve this one. So I'm going to call that my angle theta. Tangent, starting here on the inside here. So the tangent of theta is equal to 5/12. So tangent is opposite over adjacent. So straight across from the angle there is your opposite. This is your hypotenuse. This is your adjacent. So this is my 5. This is my 12. And I don't know what the hypotenuse there is, so I'm just going to call that x. So I'm going to use my Pythagorean theorem. So 5 squared plus 12 squared equals x squared. So 25 plus 144 equals x squared. Take the square root, and we end up getting 13. So my hypotenuse up there is 13. So if you remember how this goes, the sine of theta, we're making this here be theta, is equal to my opposite over my hypotenuse. My opposite there being 5, my hypotenuse there being 13. So we simply get 5/13. So that's what this is. Similarly here for the next one, I can draw out a triangle. This here is my theta, so I can say the cosecant of theta. So I'm going to come over here and I'm going to work through the cosine. So the cosine of theta is equal to my adjacent over my hypotenuse, which I've already been given, and I've been told that's 7/25. So I can put those values now on the triangle. So straight across from the angle there is my opposite, which I don't have, so I'm going to call that x. This is my hypotenuse, straight across from my 90-degree angle, and so that is 25. And then this other side down here that makes up one of the sides of the 90-degree angle is my adjacent side, and that's 7. So plugging those into the Pythagorean theorem, we have x squared plus 7 squared equals 25 squared. Going to subtract 49 from both sides. Take the square root, and I get 24. So this opposite side there is 24. Now, we know cosecant over here is the inverse of the sine. And your sine is your opposite over your hypotenuse, so cosecant has to be a hypotenuse over opposite. Well, my hypotenuse there is 25, and my opposite there is 24. So I get 25 24s. So the cosecant of the inverse cosine of 7/25 is 25/24. So our learning targets here, I can solve equations by using inverse trig functions, and I can find the values of expressions involving trig functions.